So today we're looking at what's called the fundamental theorem of algebra. And basically what we're going to be doing is exactly what we've been doing. Okay? We're not going to really add anything to it except for the fact that we have been looking at, all the graphs we've been looking at are always intersecting the x-axis. So everything we've been looking at, if it's a cubic function, it crosses the x-axis twice. Okay? But what if we have one to where it only crosses the x-axis once? Okay? So in that situation, we have one real solution, but we have two complex ones. To where when it's complex, that means that when you do the quadratic formula, you're going to end up with taking the square root of a negative number. So we're going to end up with taking that nice imaginary number I and using that today. Okay? But first thing we're going to do is just looking at roots again. So we've learned several important properties about real roots. So it says a real number r is a root of the polynomial equation p of x equals 0 if. Okay? So if I put r in for x, I get 0. Okay? And for number 1, that's what you should have done, right? Okay? How many of you got 0 for number 1 and said it was a factor?
Yeah, I did.
Okay, all right, good. Okay. Number 2, r is an x-intercept of the graph. That means that at the value of r, it's going to cross the x-axis there, which means then that x minus r is a factor. Okay? Because when I write it in factored form, if I have a 0 or a root of r, then I write it as x minus r. When we divide by x minus r, we get a remainder of 0. And then we can say that it's a 0 of the polynomial. So all those things are actually referring to the same thing. Taking zeros, writing them as factors. If we divided, we would get a remainder of 0. Okay? Each of those things. So what we're going to do is we're going to look at writing polynomial functions with the given zeros. Oh, we've already done this. Because I showed you that if we find the zeros, we know how to write it in factored form, right? We're going to throw one little side note into this that I'm going to help you with, because I don't want fractions in your answer. Okay? In the book, they're going to show them to you, but I'm going to show you how to not have fractions in your answer. Okay? Now, so if I want to write this in simplest form, that means that the first thing I have to do is write it in factored form. So if I have a 0 at negative 1, how do I write that as a factor? As x plus 1. Okay? Whenever we take zeros and write them as factors, it's either x plus something or x minus something. And whatever that is always going to be the opposite of what the 0 is. Okay, let's take 4 now instead. We'll wait for the 2/3. What about 4? What would that be as a factor? Okay, x minus 4. Now the other one we have here is going to be what? No. What is it just with that number? X minus 2/3, right? Okay. Well, I'm going to show you what to do when you have a fraction so that you don't end up with fractions in your multiplication. Because how many of you would rather avoid fractions if you could? Okay. All right. It's almost unanimous. Okay, which is what I thought. So here's what you do. It's very simple. Your denominator that you have, you're going to slide it over and move it in front of the x. So it's going to become the coefficient of x. Right, so we're going to take this 3 and I move it to here. So we have 3x minus 2. All right, so let me prove to you that that's legitimate. So if 3x minus 2 is a 0, okay, then that means that, or is a factor, that means that 3x minus 2 equals 0, doesn't it? Okay. So, Mr. Prentice, what would I do first here to solve this? Okay, add 2. So we get 3x equals 2. And then what do I do, Becca? Divide by 3. So x equals 2/3. Hey, there's our 0, 2/3. Okay? So if you have a fraction as a 0, and you don't want to work with fractions, you take the denominator, slide it over, and put it in front of make it the coefficient of x. Okay? It's as simple as that. All right? And now we're going to multiply. So we've worked on multiplying, and so we're going to use those multiplying skills a little bit more. Okay? I do not want it as fractions. Okay? All right? So we're going to multiply this out. So we're using our skills for foiling and multiplying. So this equals x squared. I'm going to put the first two together. X squared minus 4x plus x minus 4. And then I'll multiply that by 3x minus 2. So we'll simplify it. How many of you, when you multiply two binomials together, how many of you can go from here to here without that middle step? Okay, all right. A couple of us can. And you should be able to, because if you know how to factor this, okay, then you should know how this works. That all I need to do is take these two numbers. When this number here is 1 and this number here is 1, when I multiply these together, my middle term is going to be the sum of these two numbers with an x. Okay? 1 plus -4, -3. And then now we need to do that multiplication. Okay? So take the method that you like the best and use it then. Okay? How many of you like that table method the best? Okay? How many of you like doing it vertically? How many are just going to do it horizontally when you write it down? Okay? Most of you, because that's what you're used to, so that's what you want to do. Okay? But just remember, if you're going to use a table, then you're either going to have 3 rows or columns, and then the other one is only going to be 2 of them then. All right? So I'm going to multiply it, but I'm actually going to do vertical to find my answer, though. I'm going to line things up vertically. So when I just multiply both of these by x squared, I get x cubed minus 2x squared. Negative 3x times 3x is negative 9x squared. Negative 3x times negative 2 is plus 6x. So all I'm doing is, I like having my like terms vertical of each other, so it's easier to combine them, and so I'm going to write it that way. Oops. Negative 4 times 3x is negative 12x, and plus 8. So when I add them together, this should be a 3x cubed, okay? I think I missed that, didn't I? Okay. So we have 3x cubed minus 11x squared minus 6x plus 8. Now the thing is that if you did it with fractions, okay, then you would end up with x cubed. You would end up basically taking all these and dividing them by 3. Okay, so if you had it as a fraction, then I would have x cubed minus 11/3 x squared minus 2x plus 8/3. Okay, all right, if you wanted to leave them as fractions, but I wouldn't. If you don't like working with fractions, it gets hard to add fractions and subtract them. So to avoid it, When I have a 0 that's a fraction, I'll take that denominator and just slide it in front of the, make it the coefficient of x. Okay. And that way when you're done, you don't have to deal with any fractions because, as most of you said, you don't like fractions. Okay? And I'll go along with you. That's okay. Okay. Now, right, one of the things that we've learned, been working with, is, and we did this with the ones we were doing in the last lesson, says every polynomial function of degree n greater than 1 has at least one 0, okay, where 0 may be a complex number. And complex numbers are when you found zeros and you're working with I. Okay? You guys remember doing that in chapter 5. You had i's all the time. Okay? All right? So what's going to happen sometimes then is that we end up using our quadratic formula, we end up taking the square root of a negative number. And when we take the square root of a negative number, that's when you ended up with I in there because it's a complex number. And it actually represents a situation where the graph does not cross the x-axis. So we know that if the graph crosses the x-axis, that I can find those zeros even if I have to do it with the zero finder of the calculator. But if they're complex, the only way to do it is with the quadratic formula or completing the square, whichever one you like to do the best. So we're going to be doing the exact same thing we were doing with the ones in the last lesson, finding the zeros. It's just that now we may end up with zeros that are complex instead of all of them being real. Okay? So here we have fourth degree polynomial. There's 5 terms. Can I factor that? Have we learned how to factor that? No, only if I know the zeros, right? If I knew the zeros, I could write it in factored form. So our first step for doing this then, since I can't factor it, is going to be to graph it and find the zeros. So we're going to be using the exact same thing we've been doing. Right? It's just that now there might be times where you end up with complex roots instead of, or complex zeros instead of all of them being real. Thank you. Happens once in a while. Okay, so type it in and graph it. So let's take a good look at this graph for a moment. How many zeros do you see? 2 of them. And what's the multiplicity of each of those zeros? Okay, the graph just goes right through the x-axis, so it just crosses the x-axis. So those have multiplicity of 1. Well, if I add 1 and 1, what do I get? 2. But this function has degree 4. So what's happening is that somewhere on this graph, okay, there's some other things going on. It doesn't just go down and come back up. All right? Now, I know that this graph, from my experience, goes down and comes back up. And we'll talk about that in the next lesson, why I know that. But, so I'm going to change my window for a moment. And I'm going to make my y's axis bigger so I can see what's going on. So I'm going to try negative 50. Pick a bigger number, all right, and graph it. Actually, I'm going to go to the table. If I look at the table, see these numbers here? Okay? The numbers between the zeros are the ones I'm looking for. Right? So we have 0 at -1, 0 at 4. So I know this graph goes down to at least -78. Okay, because that's the smallest number I see, right? And so if I go to my window, then I'm going to go past that, so I'll go to 85. Pick some random number, right, and graph it. Okay. What's that? If you want. Okay. So you can see that this graph, if you look at it, it comes down here and moves over a little bit and then comes up sharply, okay? It doesn't just come down and go back up, okay? If it was a quadratic, it would just come down and go back up nicely, but with this, the fourth power, okay, then it's going to do a little stuff down here. Sometimes it may come down, go back up, come down and go, all right? But in this case, it just does that. Now, do I need to worry about that? No, not necessarily. It just tells me that there's something else going on there. Okay. All right, so what were those zeros we found? -1 and 4. Okay, so we're going to use -1 and 4, do synthetic division to get it down to a quadratic. Okay, so I'll use -1 first, and then I'll use 4, because I'm going to use -1 first because it's an easier number with the bigger ones. Does not matter which one I use first. Okay. It's just in this case, because I have 2 zeros that I know, I'm going to do synthetic division twice, once for each 0. After I do it with the first 0, then I'm going to use the other one to do it, to follow it up. So we bring down our 1, get -1, -4. Multiply them, we get 4, so we have 9. -9, so -36, times -1 is 36, we get 0. Okay. So, which I better end up with 0 when I'm done, right? Because it is a 0 for the function. Now, I'm going to use 4, and I'm going to use it with the numbers I just got. Okay? Because I've taken this quartic, and I've reduced it to a cubic, and now I want to reduce it to a quadratic where I can use the quadratic formula. So I got to use the other 0 now. What's that? Cool. Should be easy then, huh?
Maybe he's changed it.
Okay. All right, so this actually works out pretty nice for me. Because what does this mean? Okay, Josh says x squared plus 9.
So it's a plus or minus 3.
Because we went through, this is a 4th degree, 3rd degree, so now this is a 2nd degree. So this is x squared, I have 0x plus 9, and I want to find out when that equals 0. Now, could I still do the quadratic formula here? Yes, I could. The only thing is b would be 0. Okay, so that means you don't have any first term. Okay? So I could do -0/2 times 1 plus or minus 0 squared minus 4 times 1 times 9 divided by 2 times 1. Okay? I could set it up like that and do the quadratic formula. Okay? But it's a whole lot easier just doing this. So we subtract 9 from both sides. What happens when I take the square root of a negative number? Okay, so what's the square root of 9? So the square root of -9 is 3i. So this is going to be x equals plus or minus 3i. And if I use the quadratic formula, I would have came to that same conclusion. So my answer for this problem then is negative 1, 4, and plus or minus 3i. So it's not just the real ones I'm looking for. I'm looking for all possible roots, which means that some of them might be complex, okay, or imaginary. So was there anything different there than what we did the last couple days? Basically not, right? Okay. The only thing was is that when I got down here at the end, I had complex numbers instead of real numbers. Now, one thing to always notice too is that whenever we've gotten to this point here, or using the quadratic formula, what happens whenever I use the quadratic formula? How many answers do I get? 2 of them. I get the plus and I get the minus. Okay. All right. So I want you to do this one. Okay. Now, whenever you've used the quadratic formula, whenever we complete the square, we always end up with 2 roots. We end up with positive a plus bi and negative, so a minus bi. Anybody remember what those things are called? Which it probably says it up there, but does anybody remember without looking up there? Okay. Those are called conjugates. Okay. Conjugates. A plus bi and a minus bi, those are conjugates. Which means basically is that whenever we've solved these quadratics, okay, we end up with a plus or minus. Down here we end up with a plus or minus. Now also, when we did these here, when we did the quadratic formula, what did I end up with? Negative 2 plus the square root of 3 and negative 2 minus the square root of 3. So if you ever have a complex number, you always have to have its conjugate is a 0 also. Or if you have a radical like the square root of 3, you must also have the conjugate of that. Okay? And all the conjugate means is that you're going to make, if it's a positive square root of 3, then the conjugate would be, the square root of 3 would be negative. If I had a positive 2i, the conjugate would be negative 2i. Just means that the radical or the imaginary part, there's a positive and there's a negative. Okay. So what we're going to do with these is all we're going to do is write them in factored form. I am not going to make you do the multiplication. Okay, it gets a little tricky, and so I just want to make this part simple for you. Okay, if you want to do the multiplication with it, then you're more than welcome to. And for those of you who, I mean, it would be good for you to do it, but you don't have to. So if your mindset is to go on and be someone who has to go higher level mathematics, calculus, and so on, then you might want to do the multiplication. All right, but if you're not, if you're just glad to be here and can't wait for it to be over, then do it in factored form. Okay? So, for letter A, they say there's 2 zeros, square root of 3 and 1. The only thing is that there cannot be this. There cannot be this number here without there being also the negative of it. Because whenever we've completed the square, whenever we've done the quadratic formula, you always end up with a positive and a negative when it comes to square roots and when it comes to complex numbers. So if they say there's a square root of 3, there must also be the negative square root of 3. So when I write this in factored form then, we have x minus the square root of 3 for the positive one. x plus the square root of 3 for the negative 1, and then x minus 1. And for those of you who want, that's all you have to do. Okay? Just write it like that. All right. Now, the multiplication of this one, if it's just like square root of 3 or just 3i, those are pretty simple. When you get down to these ones like 1 plus the square root of 3, that's when the multiplication really gets more difficult. Okay? Initially, with these, a and b, the multiplication is actually pretty easy because this is the difference of two squares, right? Okay? And that means then that we have x squared minus, what do I get when I multiply those two numbers together? 3 times x minus 1. And all of us can do that multiplication. Okay? But I'm just telling you that you can stop there if you want, or you can finish it out. Depends on how motivated you are, I guess. Letter B. Okay. They have negative 2. Don't forget to write them as a function. So we have x plus 2 for our 0 at negative 2. We have positive 3i, so that gives me x minus 3i. And if I have a positive 3i, I also must have a negative 3i. So then this would be x plus 3i. And once again, here I have difference of two squares. Okay? And so if I multiply them out, this would be x squared. Negative 3 times 3 is what? Negative 9, okay? But then I end up with negative 9i squared. Who remembers what I squared equals? Let's see. I is equal to the square root of negative 1, right? And what happens when you square root, or when you square a square root? You get rid of it, right? So I squared would equal negative 1. Right? If I square this, it gets rid of the radical, correct? And I have negative 1 left. So what would happen if I multiplied negative 9 times negative 1? Okay, you get plus 9. So this would be x plus 2 times x squared plus 9. So here's the thing. If you ever have i's here, it's always going to be a plus instead of a minus with a complete, or the difference of two squares. Yep, you're good here. If you want to stop there, you may. If you want to stop here, you may. And those aren't bad at all. Okay, it's this next one that actually makes it a little bit harder. Okay, letter C, we have a 0 at 5. Okay, I can do that, x minus 5. Now, all of our zeros are the opposites, right? So if I have 1 plus the square root of 3, what's the opposite of 1 plus the square root of 3?
1 minus.
No, what's the opposite of 1 plus? I don't care about the conjugate right now. Okay, what's the opposite of that? Negative 1 minus the square root of 3. So we would have x minus 1 minus the square root of 3. Okay, for this one here. Now, what's the conjugate of 1 plus the square root of 3? 1 minus. So if I had a 0 of 1 plus the square root of 3, I also have a 0 of 1 minus the square root of 3. Okay? Which means that the opposite of that is the 1's going to be negative, and the square root of 3 is going to be positive. All right, and you can stop there. Now this multiplication, that'll take you 4 or 5 lines, but you can do it. Yes, Evan.
Is it always going to be x minus and then whatever they gave you? Or
It's always going to be the opposite.
of the first?
Okay, so if this said -1 plus the square root of 3, then both of these would be positives. Okay? All right? Whenever you have a 0 that has a radical, you're always going to have the conjugate of it also as a 0. You have to have both. Every time we have found zeros, okay, look at all these answers here. Okay, anytime there's a radical, do you ever see a radical by itself without a plus or minus? No. Okay, whenever there's a radical, you got to have the positive and the negative of it. Okay? It doesn't work otherwise. Okay? All right, here's your assignment.